Okay, so let's talk about hydroelectricity with 6.9 here. And so the first thing that we need to really talk about, and I'm going to hide my camera just so I can show you these pictures, is the basics with hydroelectricity. So the first thing is that with hydroelectricity, we're essentially using the kinetic energy of moving water. And that kinetic energy, which is mechanical energy, is going to spin a turbine, which is also mechanical energy, which will then turn the electromagnet that is in the generator. And then with that, the transformer can collect the electron flow and then generate the electricity and then ship it out to the electrical grid. So that's how we get electricity. It's just exactly, well, it's not exactly, but it's similar. The whole process of generating that electricity is similar to what happens with fossil fuel combustion and other nuclear energy and that sort of thing. Um, and so the water either moves with the natural current of the river or the natural current of tides, or it falls vertically through a channel in a dam. Okay, so those are all the ways that it happens. And so there's different types of systems down here to collect that water. So again, it either happens with the natural current of the river or the tide. There just be something, some kind of equipment in there that's going to move and create, um, enough kinetic energy to spin a turbine, or it's going to fall through a channel in a dam like this right here and physically spin this turbine. Okay. Um, or it's going to, well, those are the ways that it happens. Okay. So it can be a small device, it can be a huge dam that blocks an entire river, it can be diverted from a river and travel through this system here, where it then spins a turbine. There's lots of different ways. Now, do you need to know this impoundment, diversion, pump storage? No. But you do need to know that it either falls through it either happens because of the natural current or it falls through some sort of a channel um, in some sort of a dam. Okay. Or it's some sort of equipment that causes, because of the natural kinetic energy, causes that turbine to spin. That's what you need to know. I just wanted to show you the ways that it can happen here. This is like the freshwater, like river ways and pond ways that it can happen. And this is like using tides to harness that kinetic energy. But by far, it's the largest renewable source of electricity generation globally. And so we've invested a lot in engineering our hydroelectric power plants. And so that's a good thing. But as we saw in some past notes, it's still not to the point we're not using it enough that we can replace using fossil fuels at this point. So the three largest hydroelectricity producers are China, Brazil, and the US. And like I said, we have lots of these different types of plants, but I only gave this to you for knowledge sake. You don't actually have to know these for the AP test. So um, hydropower, as you can see, makes up the bulk of our renewable energy production, and so that's a positive for hydropower. What are some drawbacks of hydropower? Well, in green, I'm going to show you the ecological impacts. I'll show you in blue font the environmental impacts, and then in red, I'll show you the economic impacts. So the ecological impacts is that reservoirs to store the water in a dam, when we create a dam scenario, actually floods habitats and it destroys forests and wetlands that are now gone. So essentially, when we build a dam, we're turning a river into a lake now. And that actually floods the area that was part of that river's watershed. So this can prevent upstream migration of fish like salmon. And so, communities need to worry about that. These salmon need to swim upstream to reach their spawning ground so that they can reproduce. So that is a real problem. It can also sedimentation can occur within the stream because sedimentation is just a natural thing that happens in river ecosystems. Sediments are carried downstream, and now you've turned this river into you have a dam there, and so you can imagine the amount of sedimentation that builds up on that side of the stream or of the dam. So that becomes a problem. This causes the upstream to become warmer because there's more sedimentation, which decreases the amount of oxygen in the water. And the rocky stream bed habitat now becomes covered in sediment, which is a problem. It just changes the type of organisms that can live there. Downstream also loses the sediment, which can be an important nutrient source, and it can decrease the water level or increase it rapidly. Dams, they can actually control the amount of water that's flowing downstream. So if they need to release a lot of water at one time, that can impact the ecosystem. And if they need to, stop the water flow, that decreases, that changes the ecosystem too. So it's less natural, it's more of a man-made, changing of that ecosystem. And that completely messes with the stream bed habitat. Downstream wetlands suffer because those nutrients that are normally carried in the sediment doesn't reach them. And so there's some environmental impacts like fossil fuel combustion that occurs during the dam construction. There's increased evaporation because now we've got larger surface areas. So areas that have a lot of reservoirs may end up having a lot more evaporation that's not normally supposed to be there. And then methane is released because of the anaerobic decomposition of organic matter at the bottom of reservoirs. So you can end up with more methane production because of that. And then there's some economic impacts. There's homes and businesses that have to be relocated if you're going to flood a reservoir potentially. And that initial construction cost is extremely expensive. It costs billions of dollars, millions and millions and billions of dollars to create a dam. There is some long-term jobs that are created though, so that's a good economic benefit actually. And then the sediment buildup that occurs with dams has to be dredged quite regularly, and it can only be removed by crane. So you've got to bring in that heavy equipment. And that needs to happen every so often. So loss of the ecosystem service from downstream wetlands can actually lead to a potential loss of fishing revenue if like salmon breeding is disrupted or something like that happens. Although reservoirs do kind of create some fishing potential, so that could outweigh that. It just kind of depends. You have to consider all those unintended consequences. So one way that they're kind of battling against this, fish that need to migrate is they're creating cement steps or a series of pools that migratory fish like salmon can use to continue their migration upstream or around or over top of dams. And so it looks pretty much like this. You can see these little ladders that they put in for the fish to move on. And so this is essentially what happens. The flow from the water actually attracts the migrating salmon because they're looking for water flowing over top of rocks. And so it kind of simulates the natural flowing of water over rocks. And so this enables the salmon to just essentially move up the ladder, which is pretty cool. Um, in some places, they're using a salmon cannon, which just pumps salmon upstream. They'll actually have people there in these pools around dams, actually putting the salmon into this salmon cannon, which looks kind of fun. And this is a tube that just carries them up over the dam or through the dam and onto the other side. So That's another thing that they're doing during salmon migration seasons. And it can be used with other non-endangered species as well. And it can also be used to get rid of and remove invader species. Okay, so what are the benefits of dams? Well, there's no greenhouse gas emissions when we produce that electricity. The initial construction does require cement and machines, so that um, you know, is an issue that causes greenhouse gas emissions. But the reservoirs and dams can, be tourist attractions, and then the jobs that are created to maintain the dams are actually a good thing. And then there's a reliable electricity source now that's generated for the surrounding area. There's no air pollution that's being released, like we already mentioned. So those are all benefits. It also allows for the control of downstream seasonal flooding when they create dams. They've used this a lot in Europe as well to reduce the amount of flooding. They can control the amount of water that's moving in the stream or the river itself. So that's a benefit. In the US, only about 3% of our dams, however, are used for hydroelectricity generation. They use them much more in Europe for hydroelectricity than we do. Like that percentage is a lot higher in Europe than it is here. But 37% of dams are used for recreation and scenic purposes, like Geist Reservoir, Eagle Creek Reservoir. We use it for recreation as well. The second most common purpose is for flood control. So, most common purpose, recreation. Second most common, flood control. And then, we do use some for hydroelectricity. I'm not sure why they didn't have the forethought to include that hydroelectric piece to dams when they were building them. I think flood control and recreation was one of the number one things that they thought about with dams back in the day. But, if we were able to convert it into hydroelectricity, that would be a huge benefit. Flood prevention is good for humans, but it deprives the river floodplains of nutrient-rich sediment that supports plant growth and the nearby wetland habitats. So you can see here what a natural ecosystem looks like. And then that's before we build the dam. And then after we build the dam, this is now what we've got. And so it just looks completely different than what it looked like prior to the dam going in, which went in right here. Okay, here's your practice FRQ for 6.9. Explain two benefits other than agriculture and recreation that people gain from constructing dams on rivers. And you can find the answer to that on OneNote, and I'll see you guys soon.